After testing the ratios of the radius test of the power series, and we make sure that the power series can be converged, then we can do the program. And let's see what is the algorithm for power series. Okay, so computer evaluation of infinite power series. And we will also talk about the algorithm of the power series. And here we want to first, if the function, so the power series function can converge, and that is from the radius test, then we will stop at n step, nth term. When the nth term is smaller, when the relations of relatively change of the nth term is smaller than the tolerance, we can stop. So the stop sign here for the program will be when the relative change of n step smaller than the tolerance, then we are done. Okay, and we want to improve always the programming efficiency. So when we want to what kind of programming we can improve the computational efficiency for power series. So to improve the computational efficiency, we will write the power series as a recurrence form. We will write the power series as recurrence form. And what is the recurrence form? Since our power series, for example, fx is equals to n from first term until to infinity, we have tnx for each term. And this tn plus 1 will be a ratio times the n step. Then we will do, for example, sum, this f equals to some number first, like t1 first. That is a sum term. And when we do the loop, we just each time looping one term and add into this sum. This is until it will hit the stop sign, we will stop programming the power series. So all of this will be in a loop with a recurrence form. So this will be how we program and how we plot the power series. So this is how we program and plot power series. Okay, and let's see the algorithm for the power series. The algorithm of evaluating infinite power series. Okay, so first, what you need to do, of course, you will check whether this can be converged or not. Um, then check converge, which means the radius test. Okay, if the radius test shows that n plus 1 step divided by n step will be smaller than 1, then it definitely will converge for this whole power series set. If not, then this program, you can of course program, but it just never will finish the looping. Then the second, if that converge, okay, if yes, then we set the tolerance. We set the tolerance, and we also set the maximum step you will looping for the loop. Why we do that? So set the tolerance because we want to hit the stop sign later. Why we do this maximum step? Just in case that this power series, if that couldn't be converged, of course, if you check the convergence, if that is correct, then the tolerance will stop the looping. If not, then the maximum step will maximum steps of your loop will also stop the power series program. Then the next, you will set the first term where t, so each term will be represented by tx. So the first term will be t1x, right? Tx. So tx equals to t1x, that is your first term. Then you also set the sum term. So because power series is a sum of all the terms, let's set the initial one where the fx will be equals to t1x. Then later you just keep updating this fx by adding more terms of t into it. Then the fourth step, you will do a loop. Let's choose a while loop. Okay, it's just more reasonable to choose the while loop. So basically, if you hit one of the conditions, either the stop sign or the maximum stop, then you will stop the while loop. If not, you just keep adding it. So let's choose the while loop with the n means how many looping you trying to add, how many terms of the power series you are trying to add into the fx. So the n will be smaller than the maximum steps. Okay, and the tolerance will be bigger than, the relative change of n step is bigger than the tolerance, then you will do the looping. If the n is over than the maximum stop, or your relatively change is smaller than the tolerance, you are done for this looping. Okay, then how we do this loop? You have this t1 as the first term, then t2 will be the radius times t1, the t3 will be radius times t2. So the tn plus 1 will be the radius times tn. The radius is basically the relationship between the n plus 1 step over n step. Then you do the sums term will be the current f, okay? So the current f plus the t n plus 1, okay? So the sum term will be always updated with your next step, okay? Then the relatively change of this n plus 1 term will be equals to, so relative will be equals to the absolute number of t, okay, t over f, so tn plus 1 over f. This f is the sum, so the sum of all the terms. Tn plus 1 is that n plus 1's term. If the n plus 1's term over f that relatively change, will be smaller than the tolerance, you are done, because basically that's saying the n plus 1 term is so small that even you add more, it won't make too much change of your overall power series plot. Then you can done. You can be done. Okay. If that is bigger than the tolerance, that means that n plus 1 step will still make relatively significant change of your whole sum, which that significant is references to the tolerance you set up. Then you still need to do more loopings, and you will update n plus 1 to go to the next step. Then you do add. Okay, you do the add. So this is how the algorithm of the evaluating the power series. You check the convergence. If that can be, it can be converged, then you set up the tolerance, you set up the maximum steps you will set for the looping. You set what is the first term, what is the sum term. Then you do a while loop using a recurrence format. The recurrence means that n plus 1 step will be equals to the radius referred to the n step. You update the sum with the current step value. You evaluate the references, which is basically the current step making change of the sum. And if that change is significant, you do more loopings. If that change is smaller than the tolerance, then you finish this whole loop. That is how you can plot. Of course, you can plot in the end, but that is basically user defined. Okay, so this is how the algorithm. And sometimes, this power series, it can be not only just one number, it can be a whole column. In that case, if you t is a vector instead of a number, the relative part will be a maximum. Okay, maximum of one of the numbers making change of the whole of that sum. So the maximum, if that maximum of the change is smaller than the tolerance, you are done. If the maximum of that term in your t vector is bigger than the tolerance, you still need to run the loop until all the term inside your t making that relative change is smaller than the tolerance, then you are done. So there are some modifications if your power series is writing in a state space format.